iterations. This happens, in many iterations, getting closer here. So let's look at the technology now in a little more detail. The main point I want to show you is how little aspects of the technology could be improved. And that's why we're looking at this apparatus in a little more detail. Now, let's start on the right-hand side of this slide, and there's a text below. And I'm going to read this text first, and then we can talk about what this means. The text refers to the schematic drawing above it, which is of an X-ray tube, in this case a focus tube, and interrupter. And I'm reading now. The bottom part contains the primary circuit with the electrolytic Reynolds interrupter. The interrupted primary circuit prompts a secondary circuit in the induction coil, symbolized in the illustration by the juxtaposition of loose and tight windings. The secondary circuit produces a current of cathode rays in the evacuated tube from the concave cathode to the inclined anticathode. Operation of the tube increases the vacuum and the electrical resistance of the tube until the circuit sparks across the gap in air A instead of through the tube. This heats a substance in a side arm of the tube, releasing a gas and reducing the degree of vacuum in the tube. If the tube is run while there is a continuous sparking across A, the operator can be sure that the degree of vacuum and with it the output of radiation are fairly stable. Okay, so you can see where it says 110 volts. That's the battery, and then the battery leads through the interrupter, and it's an electrolytic interrupter, so we actually have electrolysis going on here, and the electrode is producing air, and when it produces air, the electrode loses contact with the liquid, and so it actually breaks the current. Once the current is broken, the air goes away, and then the current is reconnected. And this was a development by this guy, the Reynolds, an instrument maker. And the technology would interrupt the current and then reconnect the current 50 to 100 times a second, which was the fastest technology they had at the time for doing so. So now we have an AC current that goes on and off, but it oscillates, and the voltage is really quite low because it comes straight from the battery, the 110 volts. And then the point of the induction coil is to step up this voltage. And on the left-hand side, we actually have this shown a little more clearly than in the schematic drawing on the right, where you can really see the primary coil and the secondary coil, how they are woven tightly and loosely, and the higher voltage is induced in the secondary coil. The voltage that you get out of the secondary or in the secondary current is dependent on the windings, but also on the speed with which the interruption takes place. That's why the Reynolds interrupter was important, because you wanted to have as many as possible. And above, sort of in the top left corner here, we have a photo of what we're talking about. So that's what an induction coil looks like, and that's also, you can see the spark gap is these two needles that are sitting at the top. You can increase the distance by between the needles, so you can increase the spark gap, as it's called, by just turning them. That's why they've got these knobs on. And to go back to the schematic drawing on the right, you can then see that this current goes into the tube, and then it has to jump inside the tube from the from the cathode to the anti-cathode, or the anode, but in this case it's always called the anti-cathode. And you can see that it goes from the cathode, which is focused. You can see the concave shape of it, and the point is here that the X-rays come out from the cathode perpendicular to the surface of the cathode. And so if you shape it in this concave form, you can make the rays converge on one particular point, which is then meant to be in the middle of the anti-cathode. And the X-rays then are produced at the anti-cathode. In this case, because it's angled like this, it will go upwards, or let's say upwards and left here. In this case, it'll again perpendicular to the anti-cathode. And then so there are many things that you can improve in this kind of technology. You can improve the interrupter, you can improve the induction coil, you can improve the shape of the focus tube, you can improve the materials, you can improve on the degree of evacuation of the tube, and the tubes also would break after a while, and so you could improve on the sturdiness of the X-ray tubes. And then one important point that it's talking about here is that if the vacuum got too high, which happened during the operation, it would basically not function stably. When you have a change in the vacuum, the degree of current from the cathode to the anticathode would vary, which would mean that the output of X-rays would vary. And this setup that we have here, when the vacuum would be too high for the current to flow through the tube, it would instead flow through the spark gap, and then the spark gap would produce gas inside the tube. It would heat, as it said there, it heats a substance in a side arm of the tube, which would then introduce more material into the gas inside the tube, which would lower the vacuum and make it function again. So as an operator, it would sort of oscillate all the time between too high a vacuum and too low a vacuum, like a governor, and it's you wanted that to happen. And another thing is that as an operator, you can hear and see that the X-ray tube is working properly, because the spark gap has a spark going across it, and it makes a crackling noise. This was very important at the time. When you were operating an X-ray tube and you were doing a photo, making an X-ray photo with it, you might expose for 20 minutes, and then you would get the photo and you couldn't see anything, and only then did you know that the X-ray tube hadn't been operating properly. But here is a way of making it visible and audible that it's working properly, and that's really important. So these kinds of things are the many, many little details that you can pay attention to improve on the technology. Let's talk a little bit more about the market. We asked the question, who is the competitor? And in fact, when doctors at the time were trying to figure out what was going on inside the body, they would listen. And auscultation was the technique of choice, where you would actually sort of knock. Sometimes you would have a hammer, and you would knock on the body and sort of listen to the echo inside the body. And that they were actually quite skilled at this, and because it was very widely used and commonly used, they had lots of practice with this, and it worked for them. They knew how to do it. For us now, it's very inferior to X-rays, but if you had never done X-rays, and auscultation was pretty much free, except of course you need a stethoscope. The iconic instrument of doctors, at least when I was growing up, if you wanted to somehow show in a movie that someone was a doctor, they would have to wear a white coat and the stethoscope around their neck. So the hearing was very much a part of the practice, whereas using high technology like X-rays was not. And let's think about the advantages. When X-rays were, as I said, good with bones, less good with lungs, really not good at distinguishing between different kinds of soft tissue. And something like the brain was extremely difficult to do, because if you think about it, if you want to make sort of an X-ray photograph of soft tissue, which is hidden all around by hard tissue, by bone, which is very good at absorbing X-rays, that's a really difficult geometry. So there were certain things that X-rays were good for. So in other words, where you could find a market, and then there were other things where it was much harder to find a market. And this thing about machinery in a hospital setting was actually novel. Now we're used to seeing technology and machinery in hospitals all the time, but this is really one of the very first points where it enters the hospital. And this matters, because if people were used to thinking of, say, electricity or machines that made a noise, that was maybe an industrial setting. It certainly was not a hospital setting, so it seemed alien, and that's a problem if you want to introduce something into this setting and people find that it doesn't belong, or they have a gut feeling that it doesn't belong. That's a problem. And this is expressed again in this expectation of the patient. So patients might find the X-ray machinery scary. They would prefer not to have something to do with it, maybe. Or alternatively, also, some patients might find that it's exciting and positive and novel and scientific in a sense of good, new, and well-grounded, and so different expectations to this new technology. And let's think about also a little more about who the customer is. We were saying before that the medical doctor is the customer, but very often this is not really the case. In many hospital settings, you'll have the administration deciding what to buy and what to invest in, and they might even have a procurement department to do this kind of thing. The way to sell an X-ray machine to a hospital might very well have to be that you go to a doctor first and convince a doctor that this is really useful. Then this doctor has to go and convince the hospital administration that it's worth spending quite a lot of money on, even though this is completely novel. And think about it, you need to have very enthusiastic doctors for this to happen. So it's a difficult sale, basically. And another thing that then is an issue is it costs money to run an X-ray machine, and you would want to have the patients that have X-ray photographs taken of them pay for it, or perhaps in the last resort, if they had health insurance, which was coming into being right at this time in the early 20th century. If they had health insurance, the insurance would have to agree to pay for this procedure, and you would need to have prices negotiated. So the market is more complex. And as hospitals and health insurances emerged and developed at this time, the nature of selling into these markets also necessarily had to change.